Hello and welcome to another Monday night Q&A. I'm joined tonight by my colleague Steve Clifton from the Technical Helpline. Good evening, Steve.
Good evening, Sam.
How was your Monday?
Oh, busy as always, busy on those phone lines and supporting across the company where we can, you know how it is.
No, good stuff, good stuff. So as with all our live Q&A sessions, I'll just run through a few house rules. As normal, we'll start off with our question of the week, which we posted out across social media channels earlier today, and we'll go through the answer to that question. Then while you're putting questions into the chat, we'll go through some of the questions we didn't get around to from previous Q&A sessions. So please post your questions into the chat, remembering there's no such thing as a stupid question, only stupid answers. Please remember to be respectful to each other in the chat, as the whole idea of the evening is that collectively we'll help each other with the aim of improving all of our collective knowledge and understanding of all things associated with BS 7671 and the world of electrical installation. So let's just remind people of what the question of the week was. So the question that we posted out today was a definition question, really. So the definition was a protective conductor connecting the main earthing terminal of an installation to an earth electrode or to another means of earthing is, and then we gave you four options. Was it the definition for a circuit protective conductor, the definition of an earthing conductor, the definition of a bonding conductor, or is it any or all of the above? So Steve, what's our chosen answer for that one?
Well, straight away we'll go in and say that the answer is B, an earthing conductor. And as you've already said, Sam, the key to questions like this rely on part 2 of BS 7671, where we do have the definitions for anything that we're unsure about. And so the possible answer A, a circuit protective conductor, if we looked in part 2, would be a protective conductor connecting exposed conductive parts of equipment to the main earthing terminal. So that didn't quite fit our question. Possible answer C, a bonding conductor. Again, by reference to part 2 of the definitions, a protective conductor providing equipotential bonding. So again, didn't quite fit what we were looking for. And then the actual answer is B, the earthing conductor, which connects the main earthing terminal of an installation to an earth electrode or to the other means of earthing. And it's always good, especially for if people are ringing in on the helpline or chatting amongst colleagues, if you get to grips with these definitions and have an understanding of the correct terminology, it often helps the conversation flow more productively, because people then can immediately identify the part of the installation that you are actually referring to. So if in any doubt, then have a read through part 2 of the definitions and you'll find most things in there. Yeah,
and it's sometimes when we talk to people on the phone, and even when we're responding to emails, we have to get confirmation, don't we? Because sometimes the terms are misused or misunderstood. So one of the first things we have to do is go back to that starting point and try and make sure that we are talking about the same thing by using the correct term.
Yeah, absolutely. Just speeds up everything immensely and helps to prevent those misunderstandings. The more accurate we can be, then the more precisely we can come up with an answer for you.
Yeah. Okay, so looking at some previous questions, we'll stick with main protective bonding. So we've had one that says, is there a maximum acceptable value of resistance for verifying the effectiveness of main protective bonding, and does the resistance value need to be recorded on a certificate? So there's no actual defined acceptable value for the resistance of a bonding conductor, because it depends greatly on the cross-sectional area of the conductor, of the cable, and the length of run. So because your bonding conductor could be anywhere between 6mm cross-sectional area and even 50mm, and then the length will be dependent upon circumstances, there's no fixed threshold. So when you are doing that, you're verifying the effectiveness of the bonding conductor. You need to do that sanity check. Okay, well, what size is it? What's my estimated length of run? What should the resistance be? Because there isn't a single value. You know, to give you a guide, if you were looking at a 50mm 6mm copper conductor, 50 meters of a 6mm copper conductor, so that's the smallest recognized size of bonding conductor, then 50 meters of that would give you a resistance of 0.15 ohms if measured at a temperature of 20 degrees C. So we are down looking at low values, but there's no single value when you come to confirm the effectiveness of the bonding conductor, and there's nowhere on the certificate to record values either. I think it's just thinking about it, it's just within in medical locations there are some defined values when it comes to bonding conductors, but outside of that there's no fixed values. Would you add anything to that, Steve?
The only thing I would say would be some practical advice that if people wanted to check a potential test result, then in the on-site guide, Appendix I, Table I1, it does have the value of copper conductors, gives you the resistance per metre of different cross-sectional areas, up to 50mm squared. So if people wanted to actually do a quick cross-check to what an expected test value would be on site, they can use the information in the on-site guide for a calculation.
Yeah, spot on. Useful table, very useful table. Okay, we'll take another one. Do I still need to measure and record prospective fault current when completing initial verification for a new installation? So do you need to measure prospective fault current, Steve?
No, not specifically. That's the key word there in your question is measure. So regulation 434.1, it says that the prospective fault current has to be determined at the relevant point of the installation. So the accepted methods of determining prospective fault current do include measurement, but they also can include calculation or by inquiry. And then similarly in Part 6, Inspection and Testing, Regulation 643.7.3.201, again reaffirms that the prospective short circuit current and earth fault current shall be either measured, calculated, or determined by another method at the origin, and then it goes on to say at relevant points in the installation. There's also some useful information that can be found in Appendix 14 on determining prospective fault current if you wanted to take that further. One of the key things in Appendix 14 is that it informs us in domestic properties. So where a consumer unit to the relevant British standard, which is 61439-3, then the maximum prospective fault current where it's declared by the distributor to be 16 kA, it's not necessary to measure or calculate prospective fault current at the origin of the supply. We can rely upon the conditional rating of the equipment to handle fault currents up to 16 kA. Another point to consider is that when measuring prospective fault current, then the person carrying out the testing should be aware of the dangers when connecting test instruments to live parts, and particularly in relation to electricity at work regulations and HC Publication Guide 25, which gives guidance on that. And so if we can minimise the amount of live testing and determine prospective fault current by another method, then that will help us comply with electricity at work regulations. And then just on the guidance that was given earlier about measuring prospective fault current at the relevant parts of the installation. So examples of relevant parts would be, at switchgear or other enclosures where protective devices have been installed, and where those protective devices are being relied upon to disconnect fault current. So at that point there, has the equipment got the adequate rating to deal with the prospective fault current that we've determined at that position in the installation?
Yeah, no, spot on. And it is, a lot of it's driven, isn't it, by the fact that out of the electricity at work regs, there's kind of a strong consideration to not measure if there are alternative methods which are acceptable. So that's where we get the inquiry thing, and also calculations. So yeah, it's good guidance, and I think this is a thing that's happened over time, isn't it? We all used to measure it if you go back sort of 20-30 years, but there's been a strong consideration. Well, do we really need to, if we can confirm that there are maximums, for example, from the DNO? So yeah, a strong consideration to not measure it if we can get an alternative method which is acceptable.
And just as well, Sam, on that point, if you think about all the live testing that we do and the voltages and currents that we expose ourselves to, look at the magnitude of what you would expect a fault current to be and the potential risk of the current that you're exposing yourself to, then it also reaffirms that message that if there is an alternative, safer way, then simply don't expose yourself to that level of risk. We're used to, aren't we, of that sort of safe threshold of 50 volts and 30 milliamps, and when you're measuring prospective fault current, very easily you're in 100 amps, often 1,000 amps. So yeah, in terms of a potential hazard, very big. Another one that we get asked often about is the removal of redundant circuits and the associated cable in domestic properties certifiable, and even if it's notifiable to the local authority under Part P. So we do get asked this question from time to time, and a lot of the time it's also when people are making installations perhaps isolated and safe before demolition occurs. So going back to the original question, is the removal of redundant circuits and cabling certifiable, and if it's in domestic, is it notifiable? Simple answer is no. The removal of redundant circuits and that associated cabling doesn't actually fall within 7671 or Part P of the building regs, and so there's no certifiable or notifiable requirements. One thing we would say is, as with all electrical activities, the person doing this work should be competent to carry out that type of task, and that would include an understanding of the potential hazards associated with the work. And we would also suggest that you strongly consider using some form of documentation to record what you've done and make sure that that's agreed with the customer before you start the process. But there's no standard generic templates for forms or for certificates for removal of work. It's all about installing new work, additions and alterations to existing, but actually completely removing a circuit, there's actually no requirement to certify that. Have you been asked those questions in the past, Steve? Yeah, I haven't, and I was interested in listening to your answer, particularly the last part about what paperwork would we recommend that people issue. Because, like you say, there isn't a generic template. I don't know. Maybe it's a future question from Monday Night Live. What paperwork do we think people would issue? Yeah,
nice, and because a slight sort of variant on that, we quite often get asked about where people have been asked to go and isolate an installation or even isolate a single circuit. Again, there's no generic paperwork designed for that, so it really is to come up with something, get it agreed with the person that's asking you to do that work, so that there's no miscommunication or confusion afterwards. Another common one, can I use a minor works certificate when replacing a circuit breaker with an RCBO? So can we use a minor works for that, Steve?
Yes, we absolutely can. So minor works are typically used for alterations or additions to a circuit, and so replacing a circuit breaker with an RCBO would come under that definition of that you then altered the characteristics of the circuit protected device. So the minor work certificate makes a provision that any required inspection and testing for the remedial work that you've described can be then carried out and then documented on that form. One of the things that people need to know about a minor work certificate is that it requires the person filling out the certificate, they need to certify that the work doesn't impair the safety of the existing installation. Because you're only making an addition or an alteration to an existing installation, it's not just about certifying your work, it's about confirming that it has no deleterious or adverse effects on the installation itself. And also, as well as confirming that all the aspects, the design, construction, and inspection and testing of the work complies with BS 7671. The minor work certificate is a sort of slimmed down version of the electrical installation certificate, but it's no less, its legal status is no less. So people still need to understand that their responsibilities for filling it out are still the same as an electrical installation certificate.
Yeah. Okay, we'll start to pick up some of the questions from the chat tonight. So one, strictly speaking, not electrical technical, but we'll have a look at it. I'll go first, says this engineer. This is relevant to the NIC. I'm 17th edition old school Spark. Can I book straight onto an 18th edition Amendment 2 course, or do I have to do the earlier courses first? Thanks in advance. There's no requirement. Both this, all the formats sit in guilds and all other awarding bodies. There's no prerequisite that says you have to have done the previous course with regards wiring regs in order to do the next one. So there'd be no issue with that. You'd be able to sign up and do the 18th Amendment 2. Obviously it would be advantageous if you'd already had some knowledge and experience of the 18th, but there's no specific pre-requirement to have done a previous version, because that's how people start, so people coming out now looking at a wiring regs exam for the first time would be able to do the 18th edition course without having done anything previously, so you'll be treated in much the same respect as that way. So yeah, I don't see any issue with any of the awarding bodies, whether it be EAL, sitting guilds or whoever, that you wouldn't be able to do that 18th Amendment 2 course. Do you agree with that, Steve?
Yeah, I'd just answer a slightly different question, because this is something we get asked on the helpline. There isn't a specific 18.2 course. There's just an 18th edition qualification that just so happens that if you take it now, it includes Amendment 2. So because some people often ask us, like, is there a bridging course, or I've got the 18th edition, now Amendment 2's come out, do I need to take a one-day update course? And again, as you've just tied in with your answer there, Sam, the answer is no. There's no previous requirement to have done anything, and there isn't a separate course. It's just a case of that when you sit the exam now, it includes Amendment 2.
Yeah, so there'll be X number of questions out of the 60 that are about Amendment 2, because they did, didn't they? Was it 16th or 17th? They did have a course which was specifically for one of the amendments, but they haven't done that again since, have they?
No, that's right.
Okay, looking also, we've got a question. Why would you fit a clean earth with a 32 amp ring main in a residential block of flats? Yeah, I'd struggle to understand why that was done. Normally, we associate a clean earth with equipment that uses the earth as a functional reference for some functionality provided by the equipment, and therefore it wants a clean earth which isn't dirtied, for want of a better phrase, by other circuit protective conductor currents or leakage currents from other circuits. So that's normally the purpose of a clean earth. Can't think of a reason why you'd want it in a residential scenario. Just off the top of my head, I'm only thinking, has it always been a residential, or is this something that was originally offices or a workplace which has been converted, and it might be a hangover from that? But no, I can't think of a reason why you would install it for residential use. Any thoughts on that one, Steve?
Nothing specific, but no, just picking up on the point that the reason for the clean earth is to prevent noise and signal distortion. That I just jotted down 3 things on the top of my head. So one was potentially something like a CCTV system where you don't want to degrade pictures, possible for a broadband or something like that, a router for a computer, a communal router service, or a communal TV or something like that. So I don't know for definite, but perhaps something that involves transmission of a signal that wouldn't need corrupting. That's the only things I could possibly think of.
Yeah, no, it's a good shout. Those would be the things most susceptible to noise, wouldn't they? So yeah, but yeah, it'd be interesting one. Perhaps go back and do some investigation, but perhaps like with many other installations, there might not be too much information about the original design intent that's available to look at. Another one, evening guys, on an EICR, if a 3-pole fan isolator in the bathroom, zone 2, mounted into the ceiling. So I guess you're looking at possible classification codes. I think you've got to be careful with, normally we would put switches and isolation devices on the ceiling, potentially because that takes them outside of the zones. So within zone 2 we shouldn't actually have any switching devices, but just be careful that 2.25 above the finished floor would be the end of zone 2. So if they are on the ceiling, they might well be actually outside of the zone because it's limited vertically at 2.25. Even if it was outside the zone, you'd still think that it would need to be suitable IP rating for that environment. So we'd suggest through safe isolation having a look to see if there was any moisture, condensation or water ingress into the switch, because you might want to consider it potentially hazardous if there were. But yeah, just purely because of its location, have a look at its actual dimension to confirm whether or not it's outside of the zone, and then think even if it's outside of the zone, it should still be suitable for the environment in which it's installed. So perhaps a bit of safe isolation and a bit of visual inspection within the device itself. Would you think about anything else, Steve, on that one? Bit more information needed, maybe?
Yeah, I mean, the only thing that I would add to that is that we often get these calls, is this a one-off? Is this a private customer? Or is this something like a housing association or local authority where you've identified an issue, but then it is going to be then replicated in multiple, dwellings? And so if it's going to be replicated in more than one dwelling because it's a common thing in a local authority, in a block of flats, for example, where they've all been wired the same, then you would also, if you thought it was an issue, or you'd also then need to take views on, the clients and how they want to then manage. It almost then becomes a sort of risk assessment association with them, how they want to manage the situation going forward. So I think you always need to think, a bit more sort of broadly as to, if it's just a one-off, and it's within your control to do something about it, then yeah. But otherwise, you might need to take that wide advice from a social housing provider, something like that, about how they want to manage and protect the safety of their tenants.
Okay. On an EVSE, so I think we're talking about an EV charging install, I have a TNS earthing arrangement. The gas meter is external next to the electric vehicle charging equipment. With regards to simultaneous touch between the extraneous gas and true earth, would you recommend converting to TT? Okay, so we would always recommend avoiding giving people the opportunity to simultaneously access different potentials, and in a situation like that where we're most likely going to have the electric vehicle charging connected to the TNS earthing arrangement, and if this gas meter truly is extraneous, therefore there could be a potential difference. What we need to think about though is ultimately, is the service pipe work from the gas meter actually then going internal into the installation, in which case then it could be bonded when it's internal, so therefore we'll have maintained that equipotential between the two different devices. If it's not, again I'm thinking out loud, perhaps because at some point the service pipe work changes to plastic and therefore it isn't bonded within the installation, so we've only got this external bit of extraneous in simultaneous contact with the TNS earthing arrangement, then you would try and remove that. Now you wouldn't necessarily have to TT it, although that would be something that you could do, and then you've effectively brought everything back to a true earth potential. It may be more practical to put physical barriers up, box in pipe work so that it can't be physically touched. That may be a more practical approach to putting an earth rod in. But yeah, if they truly are different potentials, and there's the potential hazard there then of somebody coming into simultaneous contact with the different potentials, you would need to consider it. But again, a little bit more information needed, because bonding might be the solution. Boxing in or through barriers or enclosures preventing simultaneous access, and if neither of those is practical, then perhaps TT is your solution. But yeah, again, a few unanswered questions, but you've got all the options there, and it's just you need to choose which one's most practical, because yeah, we want to prevent that simultaneous access to different potentials. Okay, another one which is very common since Amendment 2. Do you foresee any changes in the Type AC RCD testing regime? Being more specific, as it looks like currently B-type testers results on A-type is okay, providing the 1 times test is okay, if the note paragraph is understood. Well, in response to this engineer, very much depends on whether you're looking at Amendment 2 compliant, because that's clarified very much now that regardless of the RCD type, we're only doing a ×1 test on the AC range. So what I would suggest is have a look at Amendment 2. We've run plenty of webinars and information on RCD testing specifically, but there's been quite a shift in the industry to make it clear that we don't need to do a lot of testing. We're far more concentrating on selecting the right type of RCD for the application, and then doing a simple test at ×1 on the AC scale, and then relying on the product testing to confirm full functionality. We're getting an awful lot of questions still on RCD testing, aren't we, Steve?
Yeah. It's a sort of a similar process, I think, that sort of pat testing went through a few years ago, where originally, people pat testing were trying to reproduce the type testing that had been done at the manufacturing stage, and the testing equipment and the ability to do it, just didn't exist. And so pat testing's evolved so that we, slim down the inspection and testing that we do. And I think it's the same thing with RCDs. That most people out in the field simply don't have the test equipment that can reproduce the sort of testing regime that RCDs go through at the manufacturing stage. So recognising that, we're just doing something that proves the effectiveness of the RCD, without going back to sort of trying to type test it as the manufacturer would.
Yeah. Got a question about SPDs. Hager SPD boards say that they don't need overcurrent protective devices protecting the SPD, so do we still need to put them in? Well, 7671 says that the surge protective device does need overcurrent protection. The question it raises then, has the Hager device got that built in? Because we're certainly aware of some SPDs coming as a packaged unit with the overcurrent protective device already built in. So I'd suggest just checking that with the manufacturer of choice, because the SPD will definitely need an overcurrent protective device in some form, whether that's a separate component or whether it's built into the SPD. That's really down to the choice of the manufacturer and how they've packaged their equipment. Would you add anything to that one, Steve?
Only just the BS 7671 requirement that failure of the SPD should leave the installation operational, which is why you can't then rely upon the DNO's device, because if it takes the DNO's device out, the installation is not then operational. So that's the reasoning behind it. So if you said, Sam, it's got to have some sort of its own device, otherwise it's not compliant with 7671.
Yeah. We've got a question from one of the engineers about the route into the organisation that we'll try and answer. There's a few of them in, but while we're doing that, we'll have a look at. So, what's the guidance? Going back to our original bonding question, what's the guidance with verification of bonding when you can't find the connection but visible at the MET, and when testing you're likely to get a measurement from a parallel path? So yeah, this is a very common scenario in that we can see that there's a bonding conductor leaving the MET. We can't find where that clamp is making connection with the extraneous conductive part, but we could do some proof through measurement. So for example, if you disconnect that bonding conductor from the MET, so now you've got one end disconnected and potentially only one other end then where it goes onto the clamp. You could measure from the disconnected end to the suspect pipework. You would need to then either remove or consider other parallel paths, because for example, if that's onto, let's say, the metalwork for the boiler, and then the boiler has got an earth and the metalwork to the boiler's got metal to metal contact with the casing of the boiler, it's likely to pick up a path through that CPC. But you could then identify that CPC and consider removing it to remove that parallel path. So it is possible through measurement to verify that if you disconnect the end of the conductor, and then if you've the advice then is, if you have verified through measurement that it is bonded, it's just the case that you can't get to the location of the bonding conductor, then with regards EICRs, we'd suggest that that's a C3 scenario, in that it is safe for continued use, but it could be improved and to make it compliant such that the connection is available for future testing and inspection as it should be. So yeah, depending upon really about what access you've got, how much time you've got to complete your condition report, but yeah, there are some ways that you can go with that. Difficult one though, isn't it, Steve?
Yeah. I don't really have anything to add. I think you've just covered everything there, Sam, that the advice would give.
Yeah. Okay, so we'll try and help out this engineer. So I've been doing electrical work for about 3 years. Did go to college. I learned on site. I went to Short Course College just to get my qualifications. But the only thing I haven't got is my MVQ. I'm going to do my AM2. I've got my AM2 booked for next month. Okay, so the general requirements for qualified supervisors changed in September of last year. So that was September 2021, when effectively they raised the bar for the qualification requirements for a QS. So in order to be a QS, you would need to have an MVQ level 3, and then depending upon the scheme that you're going for, you would need a minimum of an initial verification, test and inspection qualification, and if your scheme included condition reports, you would also need the periodic inspection and a current wiring regs qualification. So yes, without that MVQ equivalent, you're going to find it difficult to progress initially to that position of QS. You'd still be useful within the industry working under a qualified supervisor or working for an organisation that's got a qualified supervisor, and then you can talk to some of the training providers about the experienced worker route. But in order to go down that route, you need 5 years experience within the industry, so you would need to get more experience. But yeah, it's from the information that you said at the moment, you wouldn't be able to look to have your own registration because you wouldn't meet the minimum qualification requirements for a qualified supervisor. Let's have a look at once again. We're massively running out of time, but we'll try and pick up a couple. So TNC supply terminated inside the flat to the metal trunking, and TNCS goes to the consumer unit. What do you think TNC termination inside the flat to the metal enclosure or metal trunking, should code be issued for that? So are we saying that we've got effectively a pen conductor up to the flat, which is terminated in the metal trunking, and TNCS goes on to the consumer unit? Okay, so it was common in large blocks of flats, in large residential installations, for the DNO to be involved in the internal distribution of energy and supplies to the flats. So that's quite often where we see we can have a pen conductor used for that distribution circuit. Now the DNO have relinquished their responsibility of that, and they will say that their responsibility ends at the initial cutouts, perhaps down in the basement at the first intake, where the supply comes into the building. So strictly speaking, that internal pen conductor would then be outside of the requirements of 7671, because 7671 says we're not allowed to have pen conductors within the installation. It very much depends on how it's been done as to whether it may be non-compliant, but if it's been done correctly, it wouldn't be considered unsafe to the users of the installation, because they wouldn't generally have access to conductive parts associated with that distribution circuit. But I'm just reading through the question again. TNC supply inside the flat to the metal trunking, and then a TNCS goes to the consumer unit. So it's almost like they've said that they'll split off the pen conductor at the point of metal trunking rather than within the consumer unit. And therefore I think if that metal trunking was accessible, it's obviously conductive because it's metal, then I think you do have to look about the potential risk, because obviously that's a live conductor, the pen conductor. That will be carrying current, in which case then that people touching the metal trunking could become a conductor of that same current. So you would need to look at, if people have access, then there's a potential shock risk there. But that's an interesting one, and would certainly warrant a bit more investigation there. Would you add anything to that, Steve?
No, I think if this was on the technical helpline, we might be asking for photographs and asking people to send it as an email inquiry if they wanted further clarification from us. It's one of those difficult ones that to try and get the picture in your head is very difficult in specific circumstances.
Yeah, no, it's a good shout, and we appreciate the engineer who's put it in the chat may even have limited, but yeah, if it's something that he wanted to provide further information on the email helpline@cirkshaw.com with some additional photographs and description might help us a little bit. But yeah, I think that's one that you'd certainly have to have a look at, because yeah, we would be concerned about people having access to touch conductive parts that were connected to the pen conductor. Last one we'll go with then today is again looking at PME. Can a PME supply be used for the shower block and the office buildings on a leisure caravan park? What's our thoughts there, Steve? Can we use PME for those types of buildings in that installation?
The short answer is yes, if they're considered to be permanent buildings. BS 7671 regulation group 708 4.11.4, it refers us to electricity safety, quality and continuity regulations, which they prohibit the connection of a PME earthing facility to any metalwork of leisure accommodation, which specifically includes a caravan. But those same regulations do then go on to say that it doesn't stop you using or considering the use of PME earthing facility as the means of earthing for other purposes, such as the installation of permanent buildings. So it comes down to dividing the site up into those which are for leisure accommodation, those which are the permanent buildings serving the facilities. And the reason behind that is that within permanent buildings we can better maintain things like epipotential zones, and particularly where we're using automatic disconnection of supply as our protective measure, it means that we can effectively marshal the installation better. If parts of the installation are exposed to elements, for example, where users are potentially got simultaneous contact between true earth and conductive parts of the installation connected to PME earth, then that's much more difficult for us to control, and therefore the use of PME for those types of buildings is not permitted.
Yeah. And just one of the engineers in tonight has asked, is this a domestic only forum? No, absolutely not. It's a completely open forum. Anybody, so it's basically anybody with a Facebook or a YouTube or a Twitter account can ask us a question that we'll try and answer. So no, not dedicated to domestic only installations. I think that's reflected in some of the questions that we've gotten through tonight, and not dedicated specifically to NIC, EIC registered contractors. It is an open forum, just something that we're trying to help the industry with. So a few questions there tonight about qualifications, and we'd be happy, really, we try and keep the Monday night to technical questions rather than requirements for registration, but yeah, if you if you contact us during the day, we'll certainly try and help with information. But I think a lot of what's been said by some of the colleagues in there tonight, so that those people looking, have a look at, there's a document, EAS, Electrotechnical Assessment Specification, which you'll find is it's housed on the IET website, which will give you information about the requirements to be registered. But yeah, if you've got any qualifications, ring our customer services team, who'll be able to talk to you about prerequisites for both qualifications and experience for registration with our schemes. Just before we disappear, just tell you some news about some upcoming events. So we've got another couple of webinars which you can sign up for. So if you go onto the EICR website, you can sign up onto the webinars now. There's one next week on vehicle charging, looking specifically at some of the changes in Amendment 2, and also looking at what's coming up in the future, because there are some changes specifically around what the grant is now applicable to. And so we've got those two webinars that are available for people to register onto now. In between those two, we will be doing another Monday night live Q&A session a fortnight from today. That'll be on Monday the 24th of July. So thanks very much for joining us tonight. I do apologise if we didn't get round to your question, but we will sweep up those unanswered questions and use those as a start next time round. As I say, if you've got some specifics that you want us to go into more detail, please do use the helpline email, which is helpline@searchshaw.com, and we'll try and answer your questions. Any final thoughts on that, Steve?
No, just enjoy the rest of your evening, and that's it.
Okay, yeah, thanks very much, and hopefully we'll see you again soon.